There is a question that has tormented the human soul since the first moment a conscious being looked up at the stars and felt something stir deep within their chest. It's a question that has kept philosophers awake through endless nights, that has driven priests to their knees in prayer, that has pushed scientists to the edge of madness in their laboratories. And this question, this ancient, burning question, is simply this: is there a grand design to the universe? Is there one equation, one single mathematical statement, so profound, so elegant, so absolutely perfect, that it could explain everything that has ever existed, everything that exists now, and everything that will ever exist? Think about that for a moment. Really think about it. One equation. Just one. An equation that would unlock every secret of the cosmos, that would reveal the hidden architecture of reality itself, that would allow us to understand not just how the universe works, but why it exists at all. This isn't just an academic curiosity. This isn't just some abstract intellectual exercise that matters only to people in white lab coats. No, this is the deepest question you will ever encounter in your entire life. Because if such an equation exists, if we can actually find it and understand it, then we will have achieved something that every human being who has ever lived has dreamed of achieving. We will have read the mind of God. Now, I need you to understand something crucial right now, right at this very moment. When I say the mind of God, I'm not speaking in religious terms. I'm not talking about an old man with a white beard sitting on a throne somewhere beyond the clouds, judging your every action. I'm talking about something far more profound, far more real, far more accessible to human understanding. I'm talking about the fundamental principles that govern all of existence, the cosmic intelligence, if you will, that decided the laws of physics should be this way and not some other way, the underlying order that makes reality comprehensible instead of chaotic. That's what Einstein meant when he said he wanted to know God's thoughts. He wanted to understand the blueprint, the master plan, the ultimate truth that sits at the foundation of everything. And here's what will absolutely astonish you, what will shake you to your core if you truly grasp what I'm about to tell you. We are living right now, today, at this precise moment in human history, in a time when we may actually be closing in on the answer. After thousands of years of searching, after countless brilliant minds have devoted their entire lives to this quest, after failure upon failure upon failure, we may finally be on the verge of discovering what we call the God equation. The theory of everything. The ultimate unification. The final answer. Let me tell you how this journey began for me, because I believe it will help you understand why this matters so deeply, why this quest has consumed my entire life. When I was 8 years old, just a small boy with no understanding of the enormous universe that surrounded me, I heard something on the radio that changed everything. The announcer said that a great scientist had just died, and this scientist, this towering genius, had left behind an unfinished manuscript on his desk, an incomplete book. The greatest scientific mind of our time couldn't finish his own work. And as an 8-year-old child, I thought to myself, how is that possible? If he was so incredibly smart, if he was a genius beyond geniuses, why couldn't he finish his homework? Couldn't he just ask someone for help? What could possibly be so difficult, so monumentally challenging that even he couldn't solve it? I had to know. I absolutely had to know what was in that book. So I went to the library. This was long before the internet existed, remember? And I started reading everything I could find. And that's when I discovered that the scientist was Albert Einstein. Albert Einstein. The man who gave us E equals mc squared, who revolutionized our understanding of space and time, who showed us that the universe is far stranger and more wonderful than anyone had ever imagined. And the book he couldn't finish, the problem he couldn't solve even after 30 years of trying, was about the unified field theory, the theory of everything, the God equation. Right there, sitting in that library as an 8-year-old boy surrounded by books I could barely understand, I made a decision that would shape my entire existence. I decided that I wanted to help finish Einstein's dream. I wanted to be part of the quest to find the God equation. I didn't know how. I didn't know if it was even possible. But I knew, deep in my soul, that this was what I had to do with my life. This was my calling. This was my purpose. And you know what happened next? When I was 16 years old, I did something that most people thought was completely insane. I went to my mother and I said, "Mom, can I build a particle accelerator in the garage?" Now, you have to understand, my parents were immigrants. They didn't speak English very well. They had no understanding of physics whatsoever. But my mother, bless her heart, looked at me and said, "Sure, why not? Just don't forget to take out the garbage." So I went out and bought 400 pounds of electrical transformer steel. I bought 22 miles of copper wire. And in my high school football field, I wound all that wire into coils and built a machine that generated 2.3 million volts of electricity, a particle accelerator right there in my garage. I'll never forget the moment I first turned it on. I closed my eyes, and I could hear the crackle of 6,000 watts of electricity flowing through the capacitor, and then pop, 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 all the circuit breakers in the house blowing out one after another. The entire house went dark. And my mother was standing there thinking to herself, "Why couldn't I have had a son who plays basketball? Why does he have to build these machines that blow up the house?" But that particle accelerator, that crazy teenage project, got me into Harvard University. And that's where my career as a physicist truly began. That's where I started working seriously on the quest for unification, on Einstein's unfinished dream, on the God equation. Now, here's what you need to understand about why this matters, why you should care about this even if you've never thought about physics before in your life. Every single time in human history that we have unified forces in physics, every single time we've discovered that things we thought were separate are actually part of the same deeper reality, it has completely transformed human civilization. Let me give you an example that will make this crystal clear. Back in 1862, there was electricity and there was magnetism, two completely separate phenomena, or so everyone believed. If you had a magnet, that was one thing. If you had electricity flowing through a wire, that was something else entirely. Nobody connected them. They seemed to have nothing to do with each other. But then a man named James Clerk Maxwell came along, and Maxwell did something absolutely extraordinary. He showed that electricity and magnetism weren't separate forces at all. They were two sides of the same coin. He unified them into a single force called electromagnetism. And what happened next? Everything changed. The modern world was born. When you turn on a light bulb, when you use your cell phone, when you watch television, when you browse the internet, all of that is based on Maxwell's unification. One equation changed everything. One insight revolutionized civilization. Or think about Isaac Newton 300 years ago. Newton figured out the laws of motion and gravity, and that gave us the Industrial Revolution. Suddenly we could build machines that worked according to precise mathematical principles. We could harness steam power. We could transform raw materials into manufactured goods. We could reshape entire societies. Or think about Einstein himself with E equals mc squared, which led to nuclear power and nuclear weapons, technologies so powerful that they literally gave us the ability to destroy our entire planet or to power it with nearly limitless energy. Each unification, each time we discovered a deeper unity in nature, transformed everything about how humans live. So now imagine, just imagine for a moment, what would happen if we unified all the forces of nature. All of them. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force, everything wrapped up in one single, beautiful, perfect equation. What technologies would become possible? What would we be able to do? We're talking about perhaps manipulating space and time themselves. We're talking about understanding the Big Bang, the very moment of creation. We're talking about possibilities that sound like pure science fiction, but might actually be real. Time travel? Wormholes connecting distant parts of the universe, even parallel universes existing alongside our own. I can see you thinking right now, wait a minute, isn't this getting a little too wild? Time travel? Parallel universes? Come on. But here's the thing, and this is absolutely crucial for you to understand. That's exactly what the mathematics tells us. When you start playing with the God equation, when you start unifying these fundamental forces, incredibly strange things emerge from the mathematics, whether we like it or not. Space and time become flexible, bendable, manipulable. The impossible becomes possible. Not because we want it to be true, not because it makes for good science fiction, but because the equations, the cold, hard mathematics demands it. Let me take you deeper into something that will completely transform how you see the universe and your place in it. You need to understand the sheer power, the almost magical power of unification in physics. Because once you grasp this, once you truly comprehend what happens when we discover that seemingly different forces are actually one and the same, you'll understand why the God equation isn't just important, it's the most important quest humanity has ever undertaken. Think about the world before Maxwell. People saw electricity as one phenomenon, lightning striking from the sky, sparks jumping between objects, strange forces that nobody really understood. And magnetism was something completely different. Lodestones that mysteriously attracted iron, compass needles that always pointed north, forces that seemed to have their own separate existence. These were treated as fundamentally distinct aspects of nature, as different from each other as fire is from water. But then Maxwell came along with his equations, 4 elegant mathematical statements, and suddenly everything changed. Suddenly, we realized that every time you move a magnet near a wire, you create electricity. Every time electricity flows through a wire, it creates a magnetic field. They weren't separate at all. They were 2 manifestations of a single unified electromagnetic force. And what did that knowledge give us? It gave us generators that could produce electricity on demand. It gave us electric motors that could convert electrical energy into motion. It gave us radio waves, television signals, X-rays, microwaves, the entire electromagnetic spectrum that we now use for communication, for medicine, for technology of every kind imaginable. The modern world, everything you see around you right now, the lights above your head, the device you're using to access this information, the satellites orbiting Earth, all of it exists because Maxwell unified 2 forces, one man, one set of equations, and civilization leapt forward in ways that nobody could have predicted. Now, let me tell you about another unification that shaped everything. When Einstein developed his theory of general relativity, he did something that seems almost impossible to believe. He unified space and time. Before Einstein, everyone thought space was just emptiness, the stage on which events happen, and time was this separate thing, ticking away independently, the same for everyone everywhere. But Einstein showed us that space and time are woven together into a single fabric called space-time. And here's where it gets absolutely mind-bending. Massive objects like stars and planets don't just exist in space-time. They actually bend it, curve it, Warp it. Gravity isn't a force pulling you down. Gravity is the curvature of space-time itself. You're not being pulled toward Earth. You're following the curved geometry of space-time that Earth creates. When Einstein published this theory in 1915, most people thought he was crazy. The mathematics was so complex, the ideas so revolutionary, that only a handful of scientists in the entire world could even understand what he was saying. But then, in 1919, during a solar eclipse, astronomers measured the position of stars near the Sun and found that starlight was bending exactly as Einstein predicted. Space itself was being warped by the Sun's mass. Einstein was right. And what came from that? We got GPS satellites that have to account for the curvature of space-time to give you accurate directions. We got an understanding of black holes, those regions where space-time is curved so severely that nothing, not even light, can escape. We got gravitational wave detectors that can hear the ripples in space-time caused by colliding black holes billions of light-years away. We got technologies and insights that have fundamentally changed what it means to be human in this universe. Do you see the pattern here? Do you see what happens every single time we unify? We don't just gain knowledge, we gain power. We gain the ability to do things that were previously impossible, things that previous generations couldn't even dream of. And each unification brings us closer to the ultimate unification, the God equation, the theory that will unite absolutely everything. Now, here's where the story gets even more fascinating, even more profound. Einstein himself spent the last 30 years of his life, 3 entire decades, trying to achieve the next great unification. He wanted to unite gravity with electromagnetism. He filled notebook after notebook with calculations, with attempts, with different approaches. He worked on this problem with an intensity and dedication that's almost impossible to comprehend. 30 years. Can you imagine devoting 30 years of your life to a single problem? And you know what? He failed. Einstein, the greatest physicist of the 20th century, the man who revolutionized our understanding of space, time, energy, and matter, couldn't solve it. He died in 1955 with his unified field theory unfinished, his greatest dream unfulfilled. But here's the beautiful thing, the truly inspiring thing about the human quest for knowledge. Einstein's failure wasn't the end of the story, it was just the beginning. Because he passed the torch to the next generation, he showed us that the quest was worthwhile, that the God equation was worth pursuing even if it took decades, even if it consumed your entire life, even if you never saw the final answer yourself. And physicists around the world picked up that torch and carried it forward. We didn't give up. We couldn't give up. Because the prize, the ultimate understanding of reality, was too important, too fundamental, too magnificent to abandon. And here's what you need to understand about where we are right now, today, at this moment in history. We're closer than Einstein ever was. We have tools he never had, insights he never possessed, mathematical frameworks that didn't exist in his time. We have something called string theory, and string theory might, just might, be the God equation that Einstein was searching for. It might be the final answer that has eluded humanity for thousands of years. Let me tell you why unification is so powerful, why it's not just about understanding but about transformation. When you unify forces, you're not just saying they're similar or related. You're saying they're the same thing viewed from different perspectives. You're revealing a deeper layer of reality that was hidden before. It's like the old parable of the blind men and the elephant. One man touches the trunk and says an elephant is like a rope. Another touches the leg and says an elephant is like a tree trunk. Another touches the side and says an elephant is like a wall. They're all partially right, but none of them see the whole truth. Unification is when you step back and see the entire elephant, when you realize that all those different experiences are aspects of one single reality. And that's what the God equation will do. It will show us that gravity, electromagnetism, the strong nuclear force that holds atomic nuclei together, the weak nuclear force that causes radioactive decay, all of these apparently different forces are actually vibrations of the same underlying reality. They're different notes played on the same cosmic instrument. Different manifestations of one single, unified force that governs everything in the universe. Think about what that means for a moment. Everything you've ever experienced, every sight, every sound, every sensation, every interaction between matter and energy, all of it can be described by one equation. The explosion of a supernova billions of light years away, and the electrical signals firing in your brain right now as you process these words, they're governed by the same fundamental law. The force that keeps electrons orbiting atomic nuclei and the force that holds galaxies together in vast cosmic clusters, they're different aspects of the same underlying reality. That's not just beautiful, that's not just elegant, that's profound in a way that touches something deep in the human soul. We are on the verge of understanding that the universe isn't a chaotic collection of random phenomena. It's an integrated whole, a unified system, a cosmos in the truest sense of that word, which comes from the ancient Greek meaning order and beauty. And when we finally grasp the God equation, when we finally see the complete picture that Einstein glimpsed but couldn't quite reach, we will have achieved something that elevates us as a species. We will have proven that human intelligence is capable of comprehending the deepest truths of existence. We will have shown that we are not just clever animals surviving on a small planet, but beings capable of reading the mind of God, capable of understanding the thoughts that created the universe itself. Now we arrive at something truly extraordinary, something that will completely shatter everything you thought you knew about the nature of reality. For the last 100 years, since the birth of quantum mechanics, we've thought of the fundamental building blocks of matter as tiny dots, infinitesimally small point particles with no size, no structure, just mathematical points in space. Electrons were dots, quarks were dots, neutrinos were dots, and we had hundreds of these different particle dots, hundreds of them, each with different properties, different masses, different charges. And physicists looked at this zoo of particles and scratched their heads and asked, why is nature so messy? Why are there so many different fundamental particles? What's going on? But then something remarkable happened, something that changed everything. What if, scientists asked, what if these particles aren't dots at all? What if when you look really, really closely at an electron, far more closely than we can see with even our most powerful microscopes, what if you discover that it's actually a tiny vibrating string, like a rubber band, like a guitar string? Not a point, but an extended object, something with structure, something that vibrates. Now think about a guitar string for a moment. When you pluck a guitar string, you get different notes depending on how it vibrates. The same string can produce an A, a B flat, a C sharp, an infinite variety of notes. The string itself doesn't change, only the vibration pattern changes. And here's where it gets absolutely mind-blowing. The same thing happens with these fundamental cosmic strings. Each different vibration of the string produces a different particle. One vibration gives you an electron, another vibration gives you a quark, another gives you a photon, another gives you a neutrino. Suddenly, all those hundreds of seemingly different particles aren't really different things at all. They're just different notes, different songs, different melodies played on the same cosmic string. Do you understand what this means? It means that everything in the universe, every atom in your body, every star in the sky, every galaxy stretching across billions of light years of space, all of it is made of these tiny vibrating strings. And the only difference between one thing and another, the only difference between you and the chair you're sitting on, between water and fire, between light and matter, is the vibration pattern of these fundamental strings. The universe is music. The cosmos is a symphony. Reality itself is the grand performance of an infinite orchestra of vibrating strings playing every possible melody simultaneously. But here's where things get truly strange, where we enter territory that seems impossible but is absolutely, mathematically necessary. These strings can't just vibrate in the 3 dimensions of space that we see around us. They need more room. They need extra dimensions. In fact, string theory requires 10 dimensions total. Not 3, not 4, 10. 6 dimensions beyond the 3 of space and 1 of time that we experience in our everyday lives. Now, I can hear you asking, and this is exactly the right question to ask, where are these extra dimensions? I look around and I see length, width, and height. That's 3 dimensions of space. Add time, and you get 4 dimensions total. So where are the other 6? Are you telling me there are 6 entire dimensions of reality that I can't see, that I've never experienced, that are completely hidden from me? Yes. That's exactly what I'm telling you. And here's how it works. Here's why you can't see them. Imagine an ant walking on a tightrope. From far away, the tightrope looks like a one-dimensional line. The ant can only move forward or backward along the rope. But now imagine you are the ant. You're actually on the rope, and you realize something astonishing. The rope isn't really one-dimensional at all. It has thickness. It's actually a cylinder, a tube. You can walk around the rope, not just along it. There's a second dimension there, a circular dimension that was invisible from far away because it was so incredibly small. That's exactly what's happening with the extra dimensions in string theory. They're curled up, rolled up, compactified into shapes so microscopically tiny that we can't perceive them. How small? We're talking about the Planck length, which is 10 to the minus 33 centimeters. That's a decimal point followed by 32 zeros, and then a 1. It's so incomprehensibly small that if you took a single atom and expanded it to the size of the entire observable universe, the Planck length would still be smaller than a tree. These extra dimensions are everywhere, at every point in space, inside you, around you, permeating all of reality. But they're so small that we simply cannot detect them with our current technology. And here's what makes this absolutely extraordinary, what elevates this from interesting mathematics to profound truth about the nature of reality. The shape of these extra dimensions determines the laws of physics in our 3-dimensional world. Think about it like this. When you blow across the top of a bottle, you get a musical note, and that note depends on the shape of the bottle. Change the shape, and you change the note. Well, the same thing happens with strings vibrating in these extra dimensions. The way strings vibrate, and therefore what particles we see, and what forces we experience, depends entirely on the geometry of these hidden dimensions. So the reason we have electrons with this particular mass and not some other mass, the reason we have gravity with this particular strength and not some other strength, the reason the universe operates according to these specific laws and not different laws, all of it comes down to the shape of dimensions we cannot even see. The geometry of the invisible determines the physics of the visible. The hidden architecture of reality creates everything we experience. Think about that. The deepest secrets of the universe, the ultimate explanation for why things are the way they are, exist in shapes smaller than atoms, in dimensions beyond our perception, in a realm that we can only access through mathematics. Now, here's something that will absolutely astonish you about string theory. Something that convinced me and countless other physicists that we're on the right track. We didn't put gravity into string theory. We didn't design the theory to include gravity. Gravity emerged automatically, inevitably, necessarily from the mathematics. When we studied the vibrations of these tiny strings, we found that one particular vibration pattern has exactly the right properties to be the graviton, the particle that carries the gravitational force. The string naturally vibrates in a way that produces gravity whether we want it to or not. Do you understand how profound this is? Einstein spent 30 years trying to unify gravity with the other forces and couldn't do it. Countless physicists have tried using every approach imaginable, and they all failed. Their theories were mathematically inconsistent, meaning if you pushed the equations far enough, you could prove that 2 + 2 = 5, which is obviously nonsense. But string theory, this theory of tiny vibrating strings existing in 10 dimensions, naturally, automatically, inevitably produces gravity as one of its consequences. We didn't ask for it. We didn't force it. It just emerged from the mathematics like a gift from the universe itself. And that's not all. String theory also unifies all the other forces: electromagnetism, the strong nuclear force, the weak nuclear force. All of them emerge from different vibration patterns of the same fundamental strings. We don't have to artificially glue these forces together. We don't have to invent new particles or new interactions to make them fit. They come together naturally, elegantly, beautifully. The theory demands it. The mathematics insists on it. This is what Einstein was searching for. This is the unification he dreamed of but never achieved. And we have it. We have a theory, string theory, that unifies absolutely everything we know about the fundamental forces of nature into one coherent mathematical framework. One equation, or rather one set of deeply interconnected equations, that describes all of reality from the smallest subatomic particle to the largest structure in the cosmos. But I want you to understand something crucial here. Something that goes beyond just the science and touches on what it means to be human, what it means to seek truth in a universe that doesn't owe us any answers. These extra dimensions, these hidden geometries, this cosmic music of vibrating strings, none of this is immediately obvious. None of this reveals itself to casual observation. You can live your entire life. You can build civilizations. You can create art and literature and philosophy, and never once suspect that reality has 10 dimensions or that particles are vibrating strings. The universe has kept these secrets hidden, and the only way we can access them is through mathematics, through the patient, careful, rigorous application of human reason to the deepest questions we can ask. We can't see these extra dimensions with our eyes. We can't touch them with our hands. We can only perceive them through the abstract language of mathematics, through equations and calculations and logical deduction. And that tells us something profound about the relationship between mind and reality, between human consciousness and the structure of the cosmos. We are part of a universe that is knowable but not obvious, comprehensible but not transparent, ordered but mysterious. And that makes the quest for understanding not just an intellectual exercise, but a spiritual journey, a way of connecting with something far larger and more magnificent than ourselves. Now we venture into territory that will shake the very foundations of what you believe is possible. We're going to explore the most extreme, the most bizarre, the most reality-shattering predictions that emerge from string theory and the quest for the God equation. And I need you to understand something critical before we go any further. Everything I'm about to tell you isn't science fiction. This isn't speculation or fantasy. These are mathematical necessities that emerge from our best understanding of how the universe actually works. Let's start with black holes, because black holes represent the ultimate testing ground for any theory of quantum gravity, for any candidate God equation. A black hole is a region of space-time where gravity is so monumentally strong that nothing can escape, not even light itself. Einstein's general relativity predicts that if you compress enough matter into a small enough space, you'll create a black hole. And we now know that black holes are absolutely real. We've detected them through gravitational waves. We've actually photographed one, captured an image of the shadow it casts against the glowing matter swirling around it. Our own galaxy has a supermassive black hole at its center with the mass of 4 million suns. But here's where things get problematic, where general relativity reaches its absolute limit and breaks down completely. According to Einstein's equations, if you fall into a black hole, you get stretched like spaghetti and eventually crushed to an infinitely small point at the center called the singularity. All the matter that falls in gets compressed to infinite density occupying zero volume. But that's impossible. Infinity isn't a real physical quantity, it's a sign that your theory has failed, that your equations are telling you they don't apply anymore. And this is exactly where quantum mechanics objects. Quantum mechanics says you cannot have infinite density. You cannot compress matter to a single point. There has to be a minimum size, a fundamental limit beyond which you cannot go. So we have a paradox, a genuine contradiction between our two greatest theories of 20th century physics. General relativity says singularities must exist. Quantum mechanics says they cannot exist. They can't both be right. Enter string theory. String theory resolves this paradox in the most elegant way imaginable. Remember, in string theory, particles aren't point-like dots. They're extended objects, tiny vibrating strings. And strings have a minimum size, the Planck length. So when matter falls into a black hole and gets compressed, it can't be squeezed beyond that fundamental limit. The strings themselves provide a natural cutoff. The singularity disappears. It's replaced by a small but finite region where string physics takes over. String theory eliminates the infinity, solves the paradox, and gives us a consistent description of what actually happens at the center of a black hole. But that's not even the most remarkable thing string theory does with black holes. In the 1970s, Stephen Hawking discovered something absolutely shocking. He showed that black holes aren't completely black. They emit radiation, now called Hawking radiation, because of quantum effects near the event horizon. And this radiation carries away energy, which means that over time, over trillions upon trillions of years, a black hole will actually evaporate completely. It will disappear. Now here's the problem, and it's a problem that tortured Hawking for decades. If a black hole evaporates, what happens to all the information about the matter that fell in? According to quantum mechanics, information cannot be destroyed. It's a fundamental principle. But if the black hole disappears, and the Hawking radiation appears to be completely random, then the information seems to vanish. That's a contradiction, a paradox that threatened the very foundations of physics. Hawking struggled with this for his entire career. And you know what finally resolved it? String theory. String theory showed that the information isn't destroyed at all. It's encoded in incredibly subtle correlations in the Hawking radiation. The information escapes, but in such a scrambled, encrypted form that it seems random unless you know how to decode it. It's like burning an encyclopedia. The information is still there in the ashes and the smoke and the heat, but it's so thoroughly mixed up that reconstructing the original text seems impossible. String theory proved it's not impossible, just monumentally difficult. This was such a breakthrough that Hawking himself, one of the greatest skeptics of string theory, eventually conceded the point. He admitted that string theory had solved a problem that seemed unsolvable. And that tells you something profound about the power of this theory, about why so many physicists believe we're on the right track toward the God equation. Now let me tell you about something even more mind-bending, something that emerges inevitably from string theory, whether we like it or not. The multiverse. When we solve the equations of string theory, we don't get just one solution. We get many solutions, perhaps 10 to the 500th power different solutions. That's more than the number of atoms in the observable universe. And each solution represents a different possible universe with different physical laws, different particle masses, different force strengths, different numbers of large dimensions. So the question becomes, which solution describes our universe? Why do we live in this particular universe with these particular laws and not one of the countless others? And here's the answer that string theory suggests, the answer that many physicists now take seriously. All of them are real. All those solutions represent actual universes that exist somewhere in a vast multiverse. We just happen to live in this one. Think about what that means. Everything you've ever known, every star you've ever seen, every galaxy stretching across billions of light years, the entire observable universe with its 100 billion galaxies, all of it might be just one tiny bubble in an infinite ocean of bubbles. One universe among an incomprehensibly vast number of universes, each with its own laws of physics, its own history, its own possibilities. In some of those universes, the force of gravity might be stronger, causing stars to burn out in millions of years instead of billions. In others, electrons might have a different mass, preventing atoms from forming. In others still, there might be entirely different particles, different forces, different dimensions of space. Some universes might be lifeless, unable to support the complex chemistry necessary for biology. Others might teem with life in forms we cannot even imagine. And in some universes, the conditions might be just right, finely tuned to allow for stars, planets, chemistry, and eventually consciousness. And that leads to something called the anthropic principle, which says that we find ourselves in a universe with these particular laws, because these are the laws that allow observers to exist. We couldn't find ourselves in a universe where atoms can't form or stars can't shine, because there would be no us to do the finding. It's a selection effect. Out of the vast multiverse of possibilities, conscious beings can only arise in universes that permit consciousness. Now, I know what you're thinking. You're thinking this sounds unfalsifiable, untestable, more like philosophy than science, and you have a point. We can't directly observe other universes. We can't visit them or send signals to them. But here's the crucial thing. The multiverse isn't just a wild speculation. It's a prediction that emerges from string theory, from the mathematics of the God equation. We didn't invent the multiverse because we wanted it to exist. It fell out of the equations whether we liked it or not. And actually, there might be ways to test it. If our universe collided with another universe in the distant past, it would leave a signature, a kind of cosmic bruise in the cosmic microwave background radiation. We're looking for these patterns right now in the data from our most sophisticated telescopes. We haven't found them yet, but the search continues. Or we might find that certain properties of our universe, like the strength of dark energy, have values that are statistically typical in the landscape of possible universes, which would support the multiverse idea. But let me tell you about something else that emerges from string theory, something that really captures the imagination. Wormholes. Einstein's own equations allow for wormholes, shortcuts through space-time that could connect distant regions of the universe. Imagine the universe as a sheet of paper. 2 points on the paper might be far apart if you travel along the surface, but if you fold the paper and punch a hole through both layers, you create a shortcut. That's a wormhole. The problem is that according to classical general relativity, Wormholes are unstable. They collapse faster than light can travel through them, making them useless for travel. But when you include quantum effects, when you use string theory, things change. String theory suggests that exotic matter with negative energy density could stabilize a wormhole, holding it open long enough for something to pass through. Do we have exotic matter? Actually, we might. The Casimir effect demonstrates that quantum fluctuations can produce negative energy densities on small scales. And dark energy, that mysterious force causing the universe's expansion to accelerate, might be a form of exotic matter on cosmic scales. So wormholes might be possible after all. Not with our current technology, obviously. We're talking about civilizations far more advanced than ours, perhaps thousands or millions of years in our future. But the laws of physics, the God equation, might permit them. And if wormholes are possible, then time travel might be possible too. A wormhole could connect not just two different places, but two different times. You could potentially enter a wormhole in the present and emerge in the past. Now, this raises all sorts of paradoxes. The famous grandfather paradox. If you go back in time and prevent your grandfather from meeting your grandmother, then you would never be born. But if you were never born, how could you go back in time? It's a logical contradiction. Most physicists think the universe has ways of preventing these paradoxes. That time travel to the past is probably impossible even if wormholes exist. But we're not completely sure. We need the complete God equation, the full theory of quantum gravity, to answer this definitively. And that's what makes this quest so exciting, so urgent. We're not just trying to satisfy our curiosity. We're trying to answer questions that touch on the deepest mysteries of existence. Questions about the nature of time, the structure of reality, the limits of possibility itself. We have journeyed together through the deepest mysteries humanity has ever confronted. We have explored the quest for unification that has driven physicists for centuries. We have discovered that everything around us is made of vibrating strings dancing in 10 dimensions. We have ventured into black holes where space-time tears apart and parallel universes branch into infinity. And now, as we reach the end of this exploration, I want you to understand something that will transform how you see yourself and your place in this magnificent universe. You are not separate from this quest. You are not simply learning about physics from the outside. You are intimately, fundamentally part of the very reality we are trying to understand. Every atom in your body was forged in the heart of an ancient star that exploded billions of years ago. You are literally made of stardust. You are the universe in human form. And here is something even more profound. You are the universe becoming conscious of itself. 13.8 billion years ago, the universe began in pure energy. As it expanded and cooled, that energy became particles. Those particles formed atoms, then stars, then planets. And on at least one planet, something miraculous happened. Atoms organized themselves into molecules of staggering complexity. Those molecules evolved into nervous systems, then brains, then consciousness itself. You are the means by which the cosmos achieved self-awareness. When you look up at the night sky and feel awe, that is the universe experiencing awe at its own magnificence. We are closer now than ever before to complete understanding. The God equation that Einstein dreamed of but could not finish is within our reach. In our lifetimes, I believe we will discover it. We will have the complete mathematical description of reality. We will understand how gravity emerges from vibrating strings. We will know why the universe has these particular laws. We will read the mind of God, meaning we will grasp the fundamental principles governing all existence. When that day comes, it will be one of the defining moments in human history. It will rank alongside the discovery of fire, the invention of language, the birth of science itself. It will prove that humanity is capable of understanding the deepest truths of reality, that our minds are powerful enough to grasp the cosmic order. But discovering the God equation will not be the end. It will be a beginning. Every previous unification opened doors to technologies nobody could imagine. Maxwell's equations gave us the electromagnetic age, everything from radio to the internet. Einstein's relativity gave us GPS and nuclear power. The God equation will do the same, leading to applications we cannot even dream of yet. Perhaps we will manipulate space-time itself. Perhaps we will harness quantum energy. Perhaps we will open doorways to other universes. Beyond technology, the God equation will give us something more precious: meaning. It will show us that the universe is not random chaos, but an ordered, comprehensible, beautiful system governed by elegant mathematics. We will see ourselves not as isolated beings on a tiny rock in an indifferent cosmos, but as integral parts of a magnificent whole, as threads in a cosmic tapestry, as notes in a universal symphony. You do not have to be a physicist to be part of this quest, but you can cultivate wonder. You can maintain curiosity. You can refuse to accept easy answers when deep questions beckon. You can teach the next generation to ask why, to seek understanding, to pursue truth with passion and persistence. Because the future depends on people willing to think deeply, who understand that the most important questions are the hardest ones. Einstein spent 30 years pursuing unification and did not complete it. But he passed the torch to the next generation. We have carried that torch forward through decades of work, through failures and breakthroughs. And now we pass that torch to you, not necessarily to solve the equations yourself, but to carry the flame of curiosity and wonder that keeps this quest alive across generations. When you look up at the stars tonight, see them differently. Those points of light are cosmic laboratories, testing the laws of physics under extreme conditions. They are the furnaces that created the atoms in your body. They are beacons showing that reality is vaster and stranger than our ancestors dreamed. Remember this. You are made of particles that have existed since the beginning of time, governed by laws we are about to completely understand. You are a temporary pattern of incredible complexity that emerged from quantum spacetime. You are consciousness made manifest, and that elevates your significance. You are not less important because you are made of atoms. You are more important because those atoms organized themselves into something capable of wonder, of love, of understanding, of reaching toward the infinite. The God equation is coming. The final answer is approaching. And when we find it, it will be because countless individuals refused to give up, refused to accept ignorance, refused to stop asking questions. Einstein was one. Newton was one. You, in your own way, can be one too. We stand at the threshold of the greatest discovery in human history. The mind of God is about to be revealed. The cosmic code is about to be cracked. And you are alive to witness it, to be part of it, to contribute in whatever way your talents allow. This is our cosmic inheritance. This is our birthright as conscious beings in a comprehensible universe. The ability to understand, to know, to grasp fundamental truths. And we are about to claim that gift. We are about to read the mind of God. The journey has been long. The quest has been difficult. But the destination is in sight. The God equation awaits. And when we finally understand it completely, we will have proven that human intelligence can comprehend the deepest mysteries of existence. So carry this understanding forward. Share this vision. Cultivate this wonder. The future belongs to those who dare to ask the deepest questions and pursue the answers wherever they lead. The God equation is our destiny. Understanding is our purpose. And the journey toward ultimate truth is the most meaningful adventure conscious beings can undertake. The mind of God can be known. The universe is comprehensible, and we are the ones who will comprehend it. The cosmos is waiting. The answer is approaching, and together we will grasp it.